So the first item on the agenda for this week is Craig has been doing some experiments with Sidekick Redis. So the Redis that we use for Sidekick has been very close to CPU saturation for a while. Last week, Igor, Matt, and Bob got us back to, what was it, like 90-odd%, Bob? From like 99%. Yeah.
So from saturated to just not saturated.
Yeah. So we still need to make more improvements there. So what Craig's been working on this week is setting up just a couple of VMs with a Redis server and then a client that sort of acts like our application but doesn't actually do any work in the Sidekick jobs. It still schedules jobs, and the jobs sort of sleep for an amount of time that is sort of matches the distribution of how long our jobs take overall. And then like you can treat those like shards, like the shards we have, but just with one box, like doing all the client work. So to try and sort of reproduce what we're seeing in production. So it's not identical, but it's a good way to test out things that are harder to test in production or would take more work to even be able to test. So he's recorded a video about that. I haven't watched it yet. I'm not sure it's a great idea to watch it in the demo because the demo will be going on YouTube and the video is also on YouTube. So like it seems much more efficient to watch that separately. Has anybody watched it so far? No. Okay. So in that case, I guess I can jump to his conclusions once I find them. Oh, I can share my screen for that, I guess, and then we can all read along together. So basically, we had sort of a couple of speculative ideas, but the basic two options we figured we had, both of which require a reasonable amount of effort, are what we were calling Sidekick zonal clusters. I think essentially that's sharding. Well, shard is kind of an overloaded term in the Sidekick context, but having multiple independent Redis Sidekick instances, which should work because Sidekick doesn't guarantee ordering. We have some places in the application where we store things on the Sidekick Redis, which need to be global, but we could equally store those on the persistent Redis, which would remain global under this proposal. So,
Sean, one thing that I was thinking in this context, or maybe we should talk about it later, but if we are going to move those things, Redis instance, should we move them to a different Redis instance just to not add onto the pile of?
That's a very fair question. Persistent. So Redis persistent is also a risk. So we have a separate issue about that. Let me see if I can find that one real quick. There we go. This is one Igor created. So this was an incident from 3 weeks ago about, so when we say Redis in our services, that means the persistent Redis. And, you know, we store a lot in the persistent Redis. We can shard that, I guess, as well. So there are a couple of options there. One is to use Redis cluster, where it like handles that for us, but we haven't got any experience of doing that. And another one is to sort of do one manual split now. And obviously, if we're adding Sidekick stuff here, oh, well, we already have some Sidekick stuff here because I think this is the, I can't even remember what this one is. Bob, maybe you remember. But yeah, basically, the idea was we could either split out sessions or database load balancing stuff from the persistent Redis, and then the next step after that would possibly be to move one of those to Redis cluster, at which point we can rest a little easier. But yes, Bob, you're right. Like if we're solving the problem on Sidekick Redis by pushing more stuff into the persistent Redis, that might not be solving a problem so much as just moving it to a different.
Well, but as long as we can keep whole functional units on one Redis, it doesn't really matter which Redis they're on.
Yes.
It means what matters is that we can break off a functional part, and there's no code that assumes that it can do related things that have to be on the same Redis server.
Yes, exactly. So, oh, sorry, go on, Bob.
But we know that this stuff is like if we're doing the work of migrating, like with transitioning and all of that things, then we might want to like only do it once.
Yes. I mean, if we have to do it twice, we will do, but like ideally we would just pick the right place in the first place. So as far as I'm aware, most of the stuff where we deliberately add something to the Sidekick Redis doesn't need to be on there. Like it's just on there because it's logical, because it's related to Sidekick. But we don't do a lot of, I was worried we would do more of this, but we don't do a huge amount of poking at Sidekick's internal state directly, except for a couple of cases, which I'll mention in a second. So yeah, so sorry, one of the options was the sort of what we call zonal clusters. So the idea was that we could have a Redis in a Kubernetes zonal cluster and Sidekick instances in that zonal cluster. And I think API nodes are going into zonal clusters soon, Jav, is that right?
Yeah, they'll be going into zonal clusters soon.
Yeah, so we'd have Sidekick nodes in there as well, all of the Sidekick shards, so like catch-all, memory bound, etc. And they'd have their own Redis. And while we were talking about that, we realized that Redis doesn't need to be in Kubernetes for that, which probably simplifies the operational work there. So we could do that because we might never want to put Redis in Kubernetes. Like, or certainly it would be probably further down the line for data stores, I'm guessing, right, Jav?
Yeah, that would be down the line.
Yeah.
Well,
oh, sorry, go on, Mike.
debatable.
Debatable. If it happens, it would be
Right.
down the line.
Right. That's sorry. That's what I was trying to get at. Like, there's no need to couple a Sidekick zonal cluster in with the API nodes to Redis being in that zonal cluster. Redis can still be on a VM. It's just a different Redis to the one that we're using now. So we have two Redis Sidekicks on VMs and some Sidekick nodes in one zonal cluster. All Sidekick nodes in one zonal cluster use that one, and every other Sidekick node, either on VMs or in Kubernetes, uses the other one. So like, it's not, what I'm trying to get at there is we've been calling this Sidekick zonal clusters, but technically there's nothing stopping us from, even if we were still on VMs for Sidekick, we could do this kind of split. Like, you know, we could.
And it could also mean two different things, because one thing it can mean is to reduce the number of jobs per second. And another thing it can mean is to reduce the number of clients connected to Redis. And that depends a bit on whether it's, like I think the original zonal cluster proposal would have all queues exist in each cluster completely separate. So then the number of well, the number of clients goes down and the number of jobs per second goes down. But if you do a functional split, then all clients, like if say the post receive queue is on a separate Redis, then all clients would still have to connect to the post receive queue. So then
Yes, that's trickier to manage.
You've reduced jobs per second on that one, but you haven't reduced the number of clients. These are two independent, strictly speaking, those are two independent variables that.
Yes, yeah, that's right. And for the assumption we were going for this was that it would be a full split. So we'd have like a full set, like everything would be processed in both. And there's obviously an open question there about what we do about the queues that are only processed on VMs because they need NFS, et cetera, but that's the basic idea, because that's essentially shared nothing as far as Sidekick Redis goes, which is nice. So the other option was something we talked about a year ago, just over a year ago, when we were wrapping up our work on Sidekick, because we have like 400 queues that we listen to in our application, and Sidekick recommends no more than a handful of queues. So if we considered that we have, I think, 7 shards, maybe one more if you count the VM catch-all as distinct from the Kubernetes catch-all. You know, what if we had essentially a queue per shard, and we could do the same kind of job splitting we do now, where some workers go to one shard and some workers go to another shard, and we can control that without application changes, but through configuration. And so that's quite a big job, but it is very attractive. And from Craig's results, it will lead to quite a big improvement, because, well, I think Jakob can explain why sticking with a single Redis instance, but drastically reducing the number of queues improves so much. Jakob, do you want to go through that?
Sure.
I don't know if you need to still meet. I'll stop sharing and you can share.
Yeah, it's easier if I share. Let's see. Prepare my browser here. There, flame graph. This is a flame graph I captured earlier in the week on the Redis Psychic primary. And I don't think there was something specific going on there. I just wanted to look in detail at something I noticed in multiple flame graphs, which is that these things, blocking pop generic commands and handle clients blocked on keys, are very big. That's where a lot of the time goes. So what I did then is to look up what those things do. For instance, blocking pop generic commands. If you look, oh, now this, sorry. I try to get to the tabs and then this Zoom thing comes down and I can't click a tab. I don't know, that's blocking pop. Here we go. So the problem with these is that they start here, right? You see the first instance of the problem. This is a list over all the queues that the client is doing a blocking pop on. And in the case of catch-all, that is a list of 360 queues. So for 360 queues, it looks if the keys exist. And if the key exists, then it tries to get work off the key and returns early. And if not, it goes into this block for keys function. And that is in here. And again, that does a loop over all the keys. So both these functions, so that's roughly the call stack of blocking pop generic command. So this whole chunk is proportional to the number of keys. So if we go from, or where keys are queues. So if we go from having 360 queues on the catch-all that this loop is going through to 1, then this thing should shrink. And the same argument goes for handle clients blocked on keys, because that one is also in here. Where are you? Sorry. Clients. So that loops over the ready keys. And then, yeah, the interesting one here, sorry, I didn't super prepare this, is, right, you can see here, it spends most of its time in unblock client. So I need to look for unblock client. Unblock client. And you then end up in unblock client waiting data. And that one is, again, iterating over, well, it needs to destroy all the, see, this thing here, the client stores the list of keys that it's blocked on. So that is 360 keys for catch-all. And then it iterates the dictionary and it looks all of these things up and needs to update these things. So again, this loop is proportional to the number of keys. And that just explains a lot of the work that is going on. Yeah, that was a bit rushed. Does that make sense?
I mean, it does to me because we talked through this yesterday.
You got the non-rushed
anybody
version.
else, does this make sense? Okay, so Marin, the basic idea here is that
you don't have to explain it for me. Like, I'll rewatch this recording 3 times to try to understand.
The CPU usage on Redis in the section we're looking at in the flame graph is proportional to the number of clients essentially multiplied by the number of keys that each client is listening to. So we have different clients that listen to different number of keys, but we have a bunch of catch-all clients that listen to about 350 odd keys. So if we can get that 300, well, this is the next part. So the single queue per shard work is quite big, like to get to the end state. But I think we can get most of the benefit by focusing on getting catch-all to a single queue per shard, because A, it's the biggest in terms of number of queues. There are 350. It's got a ridiculous config, as Jav knows. We already listen to the default queue. So this is the only shard where we wouldn't actually need to add a queue to listen to, like, you know, adding one isn't a huge deal considering we already have 400 plus, but it's a neat thing operationally, because we could start making this config change to say like some work starts going to the default queue and not make any other change to our catch-all nodes. Like they could continue listening to the same set of queues and they would still pick up that work. And in terms of the total, we'd go from listening across all shards from about 420 odd queues to about 50 odd. So it's basic, it's pretty, it's an order of magnitude just from focusing on that shard. And Craig did an experiment, which I've linked to in the agenda doc, where he tried that option. So he tried single queue per shard and just regular what we have plus catch-all is one queue, essentially. And we got about 3/4 of the gains. So in his case, he saw a 30% drop in CPU usage compared to 40% if it was one queue per shard everywhere. So that seems like the best place to start with in terms of like, that's going to be the quickest to implement, and it's going to get us most of the gains. That doesn't mean we should stop. Like once if we get to that point, we should then seriously evaluate, do we want to go ahead and make a single queue per shard everywhere? Or do we think the sort of horizontal sharding of like completely independent Sidekick Redis instances is the next best step? But I think this is the best first step.
Because it's so lopsided, right? Because
Yes.
when I started looking at this, I thought, I just did a count and I thought, okay, 400 queues, 8 shards, so they're 50 on average. But the average is very deceptive because one is 350.
Yeah.
Yeah.
And the other nice thing about that is most of the catch-all queues, well, so I say nice, most of the catch-all queues are boring, and some of them don't even do any work, but not doing any work still contributes to that flame graph Jakob showed, because we still block clients on each of those queues that does nothing. And in the past, we have removed some queues from our processing. I think like geo queues at one point we removed, for instance, because we don't use geo on GitLab.com, so we don't need to listen to those.
For now.
Yeah, exactly. So yeah, but obviously, like if we can say we will process all work and do that in a way that doesn't mean that we have a bunch of clients blocked on queues that will never actually have anything in them, that's a much better way to solve that.
So apart from geo queues, what else is not doing any work in catch-all? Do you know?
I haven't looked it up, no.
Run job queues are going to be super quiet. There's like jobs that run once a week, that kind of stuff.
Right, that's a good point. So I've looked at like, over a day that I looked at in Prometheus, we had like a maximum of like 190 queues processing over any given minute in catch-all, but that doesn't mean that they're the same 190. I was just looking at the peak. So like Bob said, like if you have cron jobs that run once a day at different times, you'll have a different cron job in each of those. But yeah, I think it would be useful to look at like what the other ones we have that don't do anything.
It'd be cool if
so
we
why
don't
would they
really
be
need to care anymore. Like if we
Yes.
only need to look at default, then we don't need to care.
Yeah, exactly. And sorry, Marin, do you ask your question?
Yeah, why do we have queues that are not, like, why do we even have those queues that are not doing much?
So
Like, is this just because it was easier at the moment to add a queue?
Intuitively, I would say it's probably one of two things. So it's either a worker that doesn't run on GitLab.com for some reason. So for instance, I think we don't run the usage ping worker on GitLab.com because
LDAP.
timeout.
I
LDAP.
don't know if
Yeah,
we have
anything
that
like
now, but that
instance wide that doesn't really make sense for a multi-tenant.
Usage ping only doesn't do the work because we run this manually in production database console, or Rails console rather. So we have a developer who is dedicated to every week going in there, running a script, looking at it run for 2 days, I think, and then like seeing if something fails. So
yeah, that's the efficiency value.
Okay.
But I'm not sure if this answers your question, Marin, but why do we have queues that are not used? Because every worker class automatically defines a queue, and that goes into the Sidekick config, and then the Sidekick server processes start putting pressure on the Redis server because the config says that queue exists, even if a job never goes in.
So the other case is that there's a worker that we accidentally don't do anything with anymore, but we forgot to delete. And like that's like technical debt. It shouldn't cause us a performance issue like it is at the moment. So we would like to get that back to relegate that back to technical debt status instead of technical debt plus contributing to Sidekiq CPU, Sidekiq Redis CPU saturation. So there are a couple of complications with this. So I haven't actually written up the epic. So like I was going to make this proposal like a sub epic of the 1 queue per shard because I think it's the first place to start with that project. I haven't written it up, but there are a couple of complications, and I'd just like to talk through those quickly because I'm sure there will be more, but I'd like to talk through the ones I know about. One that is, I'm hopeful is mostly tedious work rather than anything that's particularly complicated, is that our monitoring is by queue, not by worker. So like our dashboards are by queue, not by worker, but we do have the worker label on our metrics. So for most of those, we can switch over to worker, and then we need to switch the recording rules to worker and the dashboards and the alerts to worker instead of queue. Because if everything's in the default queue and on-call gets an alert about the default queue, that tells them basically nothing because there will be 350 workers sharing that queue. So that's not going to be helpful to anybody. The one thing we can't get easily with that is queue depth, because at the moment we can say like, you know, the queue for merges is 10 deep and the queue for post receive is 5 deep. But if both of those are in the same queue, we get that from GitLab exporter anyway. So I guess we could inspect the queue and see what the depth is for each worker, but that's, I don't know. I haven't really thought that one through yet.
I'm not really sure where GitLab exporter gets it from. And if GitLab exporter just looks at the queues via the Sidekiq statistics API, Sidekiq also don't know how deep. It doesn't make sense anymore to say how deep is the merge request queue because it just would be part of a bigger queue.
Yes.
So the observability story, it has implications for observability, and that is one of the areas where most of the work would be.
I think this is the whole reason that we are in this situation, is because we had workers that did what project
authorizations does,
authorizations does, like drop 10,000 things on a queue, and then it's the only thing that's happening for a while.
Yeah, and so like I said, some of these observability things, like anything that's exported by the application has both queue and worker, so we can mostly switch those over to worker. So they can tell us like what rate a worker is processing at, what rate we are queuing jobs for a worker, what the error rate is, etc. We can map those all over fairly easily. What we do need to look at is any other metrics we get, which are probably from GitLab exporter, which are probably using the Sidekiq API, which is based on queue, not on worker. But it will still be useful to know what the depth of the default queue is. I'm not saying we should replace them. I'm saying we should add, just to be clear. And also because we'll still have the separate queues for the other shards.
So what Bob just touched on is that there is a conceptual downside to having fewer queues, which is by having more queues, we can have more or less have fairness guarantees.
Yes, and the queue is like the unit for Sidekiq. Like, you know, passing to the command line, like you tell a Sidekiq process, listen to these queues. So that's the natural unit. And I think it was, you know, probably a reasonable decision when we did it. And it's also easier to add queues than remove queues. So that explains why we've not done this before. Is like, you know, it's harder to go in the opposite direction. And that's why I'm using default as kind of a trick, because we already have the default queue. So we don't have to remove queues. We just have to shift work to default. And then when we're confident that's working, we can stop listening to the other queues. So we can do it in a safer way. Because obviously any major change to our Sidekiq config is, you know, risky. Like we could lose jobs. And the same applies to the zonal clusters work, of course. Anything else
Sean,
about observability?
Yeah, just one comment about that. We should probably prioritize the known queues and catch-all that don't rely on NFS to begin with, because we still have that split.
Yes,
and
Craig
the
mentioned
last thing
this.
we would want to do,
Yeah.
And then the other thing, I'll just echo the concerns about, you know, we would be increasing the blast radius for failures. Like right now, our queues are fairly isolated. If there's a problem, there's a queue that depends on an external dependency and it starts to back up, it's limited to that feature. And we have, even in catch-all, I think we have like maybe some external dependency external dependencies.
Yes,
like
that aren't tagged
maybe,
properly. Yeah.
yeah. So, man, it would be great if we would maybe organize things, like, because this is what worries me the most.
Sorry, I completely missed a part off the top, Jav, and I'll just explain that, because I don't think it's going to completely answer your question, but I think it is going to partially answer it. So the idea here is that there is a configuration that lets you move which queue a worker puts its jobs in. So each worker has its own queue name, and the idea is here that the configuration would let you say to that worker, don't put it in your own queue, put it in the default queue. So that also means that we have the option to say to that worker, do put it in your own queue. So
Yeah.
You know, we have the option to like go back to having a dedicated queue for, I don't know, or say we put authorized projects in default and then we were like, oh no, this is a terrible idea. We can put it back into its own queue under this model. We're not actually deleting, I guess, queues at this point. We are just shifting.
Moving work.
Oh,
yeah.
That's
one of the
okay.
questions
That's fine.
here is one of the questions I have here, and Jarv, you maybe know more about that, is how often do we so what the current system is very flexible, and you can a lot of stuff can be in the queues, and you only make a choice of where it goes in the server config. So we have a lot of flexibility, but I don't know if we use it. And if you start sorting jobs to different shards before they go into the queue, into their respective queues, it's much harder to reorganize those queues, because you'd have to, I don't know, run some Rails command script that I think we sometimes do that, like right where we pop through a queue and toss out jobs or something. But it's about when you need to, it's about deciding early, deciding eagerly. So this current system is lazy, but that concentrates a lot of work on Redis. And if we have an eager system, then it's more efficient, but you're making these choices earlier. So do we use that flexibility now? Or how do we use that?
No,
So
we
Jav
don't.
just
I think
updated the runbook for this, I think, about how to move a queue around, and it's not as easy as we'd hoped it would be.
it's not something we do often, and I think we basically rely on having like lots of these queues and isolated workloads based off of queue. If we change that model, then we would definitely want to improve our management.
So in the example of authorized projects where it creates a crazy amount of jobs, if we sort jobs early, like Sean said, it should still be a tweakable model where either based on, I guess we still keep the selectors. So we could deploy a config change where we say, we maybe would even be able to instantiate a new shard or just a separate queue where we say, okay, this stuff is a problem right now, it goes in the other queue. But of course, that only changes jobs that are submitted after the config change. It doesn't change a problem where jobs are already in the queue, like we have 100,000 jobs in the queue and we need to do something about them. So does that matter practically, or is that not something? So I think you just, I'm sorry, I'm restating my question. I'm just double checking that how we use this flexibility.
Just to make sure I understand your question, Jakob, is the question like, how often are we doing this to redirect work in flight, and how often are we doing this to?
Yeah, it's like in flight versus changing how the system works from now on.
Yeah, stopping stuff that's going into this queue. And I think the current model can only work on the in-flight basis, but the question is like, then how quickly can we do that? And how, you know, like if we can't do that quickly enough for the current backlog to be reduced, then it is effectively the same thing.
Exactly. So and certain things can be reproduced. Like in the current model, we could deploy a config change and say stop processing authorized projects because everybody else is starving for CPU time. But that is a very clunky way of making a change, and I don't know if we even do that or if we should be doing things like that. But even if we have a model where we're sorting early, we could still do these sort of things with a server-side middleware where a job comes in and we would have some sort of dynamic config that says, oh, this is the authorized projects worker. I'm going to requeue this on a separate queue, like we have an overflow shard or something. And I'm going to redirect this because this should not bother anybody else. So
yes, so there'd be a small delay in processing like jobs that need to be requeued. But obviously, if you're making jobs be requeued, then you probably want a delay.
Yeah,
so,
but now I'm talking about capabilities that we could build, but I'm not even sure if we use those capabilities now. And if we don't use them now, we probably shouldn't make that part of the epic.
Can I just ask a question that is a bit of a separation fork from this discussion? So if we go down this route, we're going to get some savings. What did you say, 30 to 40% CPU, right?
that's what we saw in the experiments
Okay.
setup. We can't.
And that is going to buy us, let's say, a year, maybe, if we are lucky, depending on what happens with the development, what happens with the platform, and so on. Are we hitting the limits of what we can do with these two components, with Redis and Psychic? Do we need to start thinking longer term? Meaning, I'm not saying that we disband this work right now. That is not what I'm saying. What I'm saying is, once we complete this work, do we start thinking about a new component in there that will do something, change of not only configuration, but a change of architecture of how we do these things?
So like,
is this something we should
a real
think
job queue
about?
instead of Redis, for instance?
For example, like I know what I'm saying, and I know what I'm saying in a recorded call. I know how hard this is, but at the same time, we're talking here about the next level scaling. Next level scaling means we make really tough choices.
Mm-hmm.
Yeah,
so,
I wonder what, I don't know if anybody knows, but like what size Sidekick farms other people run? Like what is sort of the number of jobs per second where people
I
are
saw
going?
Mike mention in the issue that he got created when we were discussing the timeout thing. Then there he mentioned something like 25,000 jobs a second in an issue. So like,
yeah, let me just find that.
We're under 2,000 right now.
Excuse me?
We're under 2,000 right now, right?
He said I've had customers report 25,000 jobs per second. So yeah. So my initial instinct, Marin, there is that if we can make the horizontal sharding story work, then that is probably the next step after we've reduced the number of queues to whatever level we determine. But that, I did use that magic word if at the start of that. So there are some cases like the admin APIs we have, like the runbooks we have to delete jobs from a queue, that don't work if every application instance can only see one Sidekick thingy, because then somehow you need to send the same command to different application instances that can see different Sidekick Redises.
Which is why I prefer a model where you have functional, a functional split, where some queues live on one Redis Sidekick pair and other queues live on another, and everybody sees all of them.
Yes, because then everybody has to know about all of them. Whereas the nice thing, but also the trap with the other split, is that you can say, no, an application instance only needs to know about one Redis Sidekick, but then it only knows about one Redis Sidekick. So like it can't see what's going on the other instances. But hopefully we can think about these questions over the time that we work on this as well. I do think, I don't know.
Craig said the same as you, Marin, by the way. In at the bottom of his comment, he said this is his conclusion is reducing number of queues seems like the biggest win, but that's a one-time thing we can do, and we need to think longer term what we can do about growth.
Yeah, where did he comment that? I'm not seeing it.
I think that's in the comment I linked in the agenda doc, but I'm not sure if that's the one Jakob meant.
Yeah, it's the one where he says interpretation and recommendation.
Yeah, so it's in the recommendation section.
Yeah.
Yeah.
The last sentence.
I think some of the...
Okay, I'm looking at the wrong comment then, I guess.
Sorry, yeah.
It's in the epic?
No, it's the one in the issue. So the one under 2A in the doc. I also think some of the answers to this question will be affected by the other work that's happening now. So I know we're looking at like not relying on a single global database if we can, which is its own can of worms. But like we probably don't want a completely different model for how we manage our database to how we manage our job queuing. We probably will want different models, but what I'm saying is, like, if the database ends up being sharded by
It's likely
customer, say, then we would probably do the same for Sidekick, or at least look to, you know, work with that. Whereas, you know, that's a very vague answer, but
so there is a group being formed right now to answer some of those questions, like a sharding, not a working group, but a sharding team for the database. And it might not be the worst idea to actually like peek into what's happening there.
Because, and I think this is another advantage of doing this first, is that this is, however we shard in future, reducing the number of queues will increase our headroom on whatever shards we end up with, because we won't be listening to a bunch of queues. So, you know, we'll have a much more space available to us. So, and also this one's harder to do if we have started sharding already, because, you know, we need to migrate some things, and we need to migrate them in more than one place, basically. So yeah.
From my perspective, I would prefer to hold off on sharding Redis by cluster, just because my main concern with that activity is our inability to drain an entire cluster, which is something we take advantage of now. If we have Redis, for example, running in cluster,
Right.
That's a big problem.
Yep.
If we don't have horizontal scaling for Redis, then if you offset the load, like if you drain a cluster, that's going to put pressure on the other Redises and
Yes.
could cause a problem. So I would much prefer we focus on like reducing the number of queues. If we think we can get some CPU savings, I'd rather do that first, personally, just because, especially with the migrations that we're doing now, we're still kind of in the early phases of feeling out Kubernetes, and we've used, you know, draining clusters quite a bit since we've done the migration. This will probably stabilize over time, though.
When you talk about draining, you talk about is that the problem that we have a number of things that can handle the combined workload, but you take one of them out and now we cannot handle the combined workload anymore?
Yeah, currently right now, if we drain an entire zonal cluster, it's quite nice because of HBA. It's just the other zonal clusters scale up because we scale based on CPU. If we add Redis into that equation, then we may run into problems.
Right. So say we had two zonal clusters and no VMs, for instance, and like each of them are doing 50% of the workload, and we drain one of them, then that other Redis suddenly gets 100% of the workload.
So you're basically saying that Redis needs to be in its own set of clusters.
Well,
if I'm understanding correctly, then you
possibly,
want it to be separate from the application, right? And in that case, if it goes into Kubernetes, it needs to sit side by side by our application clusters rather than within them.
I think the problem is also if even if it's in separate clusters, you're going to be you would still have a one-to-one relationship between cluster and Redis, right? So
yeah,
unless if your Redis can scale just like the zonal clusters can now, it's not going to be.
You would prefer to have the purposes mixed within that cluster so that you can. Yeah, I see what you mean. Okay.
Good job. Would this be a fair like way of framing part of the concern? There is like if we have two zonal clusters, then draining one of them is a big problem. If we have 10, then it's probably not as big a deal because, like, you know, the other 9 can pick up the rest of that. So like if we're at any two, clusters don't bias as much as we'd hope.
Yeah, I think if we had 10 zonal clusters, we probably would be able to absorb the additional load. But I don't know if that would happen.
Right.
We're not prepared. We're not prepared right now for that. I mean, it would be great. It'd be great though if we could.
Yeah.
Well, I mean, not necessarily, but yeah, I mean,
yeah,
it would be a little bit more overhead for sure.
Because if we have
our tooling isn't ready for that.
If we have two clusters and they're 50-50, then if you remove one, if you drain one, then the other one has to do double the work essentially, which isn't easy to auto scale in the same way.
Right, and we have 3 right now. We could conceivably increase to 5, maybe, but I wouldn't imagine us going beyond that.
Yeah, and it sounds like if we do this and we do by ourselves, say a year-ish, we will be in a much better position to see what the Kubernetes zonal clusters story looks like for other services at that point.
Yeah.
I'm going to move on to a different complication because I wanted to talk to Bob about this briefly. Oh, actually, does anybody else have anything for the demo?
Oh, I wanted to briefly mention that the pack objects cache is very close to being enabled, but it basically is waiting for some omnibus code to reach production, and the deploy failed 2 days in a row. So we're hoping every day I'm now looking to see if it reaches production, and Matt Smiley is poised to make the change. So that's
I find it very ironic, Jakob, because I kind of pushed a bit to get the code merged in, right? Reviewed and merged in, and then everything got blocked.
Should we hot patch this in production, Marin? Like,
you know that I would.
And one thing that was interesting, slightly scary for me, but I happened to see an incident yesterday where about SLO, Appnext SLO violations on Philo 4, which is not a Git server I often hear about, but I just peeked over people's shoulders like, oh, that sounds related. And I was just toggling the feature flag so I could see the cache keys for the pack objects things it was looking up. And there were crazy numbers for repetition. So everything looked again like this is the classical CI problem. So it would have been really fun to turn it on in the middle of that, if I'm right that was it. But yeah, they did something else to make it stop. But it's just a reminder that it's not a problem that is unique to Falconario 1.
That something else was they talked to the customer and said, stop doing what you're doing. And they're like, we're using CI. Oh, maybe we made a mistake somewhere. Let's check. It's not great.
Okay. No, it's not.
But if the customer stopped doing it and then can start doing it again once we enable this, that would be a good test.
Yeah, well, that's sort of the same test as us removing the pre-clone script. But yeah, that's just a little progress blurb, and I keep hitting F5 on the version numbers of the omnibus packages. So back to you, Sean.
Yeah, so just quickly, Bob mentioned a really good complication yesterday, which is that one nice thing about the queue per worker model is that with a mixed deployment like we have now, where Canary can be scheduling jobs into queues that Sidekick doesn't know about yet, for workers that Sidekick doesn't know about yet, because they're in their own queue, and Sidekick won't be listening to that queue, that's fine. Like, you know, if you schedule some jobs from Canary that don't exist in production, they just don't get processed until production Sidekick is updated. But in the new model, because if they go to the default queue, they will fail because we can't find the constant for the worker because it's not been deployed yet. So I think there are a couple of options there. One would be to have a very specific config that we update every time to not move those workers to the default queue until they're ready. I don't like that. Another is to have some kind of custom retry. So ideally, we would just use Sidekick retries for this. But we, a while ago, set our default retries to 3, which happen in about 2 minutes. Sidekick defaults to 25 retries that happen over the course of like a couple of weeks. I don't know if I've created an issue about this. I've talked to a few people about it. What I'm going to do is I'm going to create an issue about that. But one thing I was thinking was we could set all existing workers to explicitly use 3 retries, because we don't want to bump those up because we might be putting extra load on Sidekick for retries that are never going to succeed, and then set the default to back to 25 and let all new workers retry 25 times, which would be plenty enough to wait until that work is actually available in production, and would also nudge us towards having a sensible retry policy.
Or what we could also, isn't the retry just an exception? Like a special type of exception?
Sidekick does some things. Sean, what I was thinking, if we just put the retry thing in our application worker, then set the default of Sidekick back to 25, since the constant can't be initialized, it falls back to the default and everything else is...
Oh, that's a good idea. Yeah, so if the worker
I-
doesn't exist, then the retries are 25, and if it does, then it
Exactly.
uses 3. That's clever.
Yeah, I wanted to say the same thing, except I
Okay.
don't know how to do it, and you guys do. But we should be able to detect the failure reason, and if it's
Yes,
I
it
don't
should be a
it's
name error.
constant,
Yeah.
then it should get more retries.
Yeah, that's a smart idea. Thank you both. I like that one because that's I do kind of like the idea of making all new workers have 25 retries, but it's a bigger change than is strictly needed for this project.
Yeah, we shouldn't make that part of the
Yeah,
problem.
it's not
No.
really directly related, and it could cause other problems. So yeah, I like that idea.
If we do that suggestion, though, it does kind of tie everybody to, like, from now on, like, it sets it more in stone, like it's going to be 3 forever for the actual workers, which is
Yeah,
not what we
I'll
want.
write up an issue about the retries thing if I haven't already created one, because I do want to talk about this, and I was hoping that if we did the Sentry project, for instance, we could get back to that, but obviously we don't have time to do the Sentry project because we've got to do the Sidekick project, so there's always more to do than we have time to do, basically. I don't think the retries is anywhere near the top of our priority list. In general, it's just a bit frustrating that it's limiting us in this particular case. I think those were the only 2 complications, or the only 3 complications, I guess, with the one that Jakob mentioned about the workload shifting that I wanted to talk about on the call. So the metrics and observability, workload shifting, and how this works with our deployments. Did anybody else have anything they wanted to say about this before I go and try and write all this up into an epic?
It kind of ties into the metrics and observability, but sometimes we, like the workers I brought up, we have this self-throttling thing that workers do that check their own queue size.
Yes.
So we will have to re-implement that using something that can be shared state, like that can be, I'm saying shared state, but like, you know what I mean.
That doesn't rely on the actual queue depth, because
Yeah.
it cannot. It shouldn't. Yeah.
Yeah. So there's some workers that say, we can only process X amount of these at a time, right?
Yeah, and I'm not just talking about the limited capacity things that I was working on with the CI teams and the package teams, but also global search does something like that.
Mm-hmm.
Yeah, I linked the workers that I found at a quick glance.
I did see that. So for global search, we can kind of punt on that because we're not proposing to rename their queues to default just yet, but it's definitely worth thinking through. So thanks for bringing that up, because there were a couple that you mentioned that would go into default and we would need to handle somehow.
I think this is still, I just want to emphasize, it's really nice that we can try this all out, but only focus on part of the queues, because this lopsided thing where default is so huge, because we'll discover so many problems that we don't know about yet and learn how to deal with them, and have some flexibility in dealing with them or not.
Yeah.
One question that I had in the doc was like, as you mentioned, I do like the idea that we can just move some stuff over to default and then like remove some queues already. But I'm wondering if we should, like, if we're going to be playing for is this a configuration thing, or is it going to be like a hard-coded thing? Like, are workers opting into, I don't need my own queue, and then we have configuration that says that's default? Or
no,
do we have...
I think initially from the default GDK, source install, omnibus install, charts install of GitLab, and indeed for GitLab.com, initially everything will continue to use its own queue, and we will allow you to opt in through configuration to saying workers matching this queue selector, or this worker selector, I guess it would be now, or virtual queue selector, let's, whatever we call it, go to this queue, concrete queue instead.
So then we have a thing in the application that says this worker, we approve you can do fancy things with queues.
Yes. So essentially each worker would check its own attributes against whatever selectors there are and say, like, am I going to my own queue, or am I going to a queue that based on matching these selectors? And if there are no selectors matching, I go to my own queue.
Cool. So that means that we, like, as soon as we've done this, we've got it all figured out and we just do it.
Yeah, as soon as we've done this, it's easy street.
Got it.
No, it's important, I think, to do this whole thing in a way where it's configurable and we don't change everybody else's config while we figure out what works well.
Yeah, we might want to make other people's default config look like this in future. But I mean, 14.0 is in June
Then we
now.
also don't need to think about migrating other people's.
Exactly,
stuff
because
around.
migrating for us is just basically going to mean listen to those queues until they've stopped processing, at least initially, and then stop listening to them, and maybe do something special for scheduled jobs, and that's kind of it. Whereas if we need to like migrate it for self-managed users, then we actually need to put in the work there. But if we're specifically focused on GitLab.com and specifically focused on the catch-all shards, then we don't need to do that. So yeah.
Yeah, so it reduces the amount of work, but we still expect a big benefit, both from Craig's experiment and from the theory.
Yes.
That's the brilliant part about only looking at catch-all.
So we expect we could reduce the number of queues we listen to by 2 orders of magnitude. And if we specifically focus on catch-all, we can do the first order of magnitude just on 1 shard. That's how bad catch-all is compared to the rest. All right. If nobody has anything else, I'm going to wrap this up, and then I'm going to watch Craig's video about his demo, his experiments, because that's super interesting as well. And yeah, have a good day, everybody.